In this tutorial, we're going to talk about section 7.2, which talks about similar polygons. Once again, let's go ahead and get started with some definitions. So the first definition that we have is similar, and when we're talking about polygons, two polygons are similar if corresponding angles are congruent and corresponding sides are proportional. Well, that's a lot of big vocabulary words, so let's draw a picture and see if we can make some more sense out of this. So let's take this picture for example. So we have two triangles here, and obviously they're not the same exact size. But let's see if they're similar. The first thing we have to look for is that all corresponding angles are congruent. So the top red angle happens to be congruent to the top red angle in the bigger triangle. And green is congruent to green, and blue is congruent to blue. So it's not just one pair of angles that have to be exactly congruent here. Every single pair of corresponding angles must be congruent in order to have anything that's similar. So we can check off the first main thing that we need in order to determine similarity. The second thing is determining if the corresponding sides are proportional. And what it means by proportional is that when you put it as a ratio, they all come out to be the same exact thing. So I'm going to pick the smaller pair of sides, which in the small triangle is going to be 2, and in the larger triangle, its corresponding side is going to be 6. Now, can this be reduced? And the answer is yes. 2 goes into both 2 and 6, so this reduces to 1/3. So what we're looking for is all the other ratios are also 1/3. Let's check out the medium-sized side. So in a small triangle it's 3. In the large triangle it looks like it's 9. Once again, this also reduces to 1/3. And the larger pair is 4 and 12, and once again that is 1/3. So I can say these triangles are similar because the ratios for all the sides are proportional, they're all the same ratio, and all the corresponding angles are congruent. And the symbol that we use for, not for congruency, but for similarity is one squiggle, just like this, like a sideways S. So let's see if we can use that in a couple examples. Okay, so here's an example. We're going to determine if these figures are similar, and then we're going to write what's called a similarity statement. So the first thing that you want to try to find out is if all of the corresponding angles are congruent. Now in this picture, notice that these triangles have a reflection. Okay, so basically if I were to take the first triangle and flip it over, I could put it right on top of this second triangle, at least for where all of the angles are. So sometimes you need to mentally turn or rotate or reflect these pictures in your mind so that you can get all of the corresponding angles and sides in the right place. So as far as all the angles are concerned, they are congruent, so we're good to go with that. Now the next part that we have to determine is if all of the corresponding sides are proportional. So let's go ahead and get that started. I'm going to do side AB, which is 15, and I'm going to put that over its corresponding side in the larger triangle. Now AB connects the purple and orange angles. So which side in the larger triangle does the same thing? And that would be side FE, which is a length of 20. Now what does this reduce to? And the answer is 3/4. So this is the ratio that we're looking for. Let's move on to the next pair. So side BC, its similar side should be 16. All right, so once again, 4 goes into both 12 and 16, 3 and then 4 times respectively. And then the last pair, we're going to do 18 and 24. 6 goes into both, 3 and 4 times respectively as well. So these figures are similar, so let's write the similarity statement. And the way to do that is I'm going to write triangle ABC is similar to triangle. Remember with the name in the same way, so the purple angle goes first, So that would be F, and then the orange angle, ED. And you can go a little bit farther with this if you want and say ratio is 3:4. So that's how we do that. And that concludes this tutorial.